Hello everyone and welcome once again to my channel. This time we are going to be having the series 2 for those that are preparing to writing the forthcoming Uniben Post-Utme examination 2025, which will be holding in the month of September, first week. So if you are in this channel and you are writing the forthcoming Uniben Post-Utme examination, this video is for you. Do well to watch this video to the very end in order for you to learn so much in this class. So on the board, we are having chemistry questions. So we are going to be looking at a total of 15 questions. On the board, we are having 5 questions. So after which, we will look at more. So let's not waste much time. Let's see the question 1. Question 1. The oxidation state of oxygen in tetraisosulfate 6 acid is. So this question is actually taking our mind to determination of oxidation number. So how do we get the oxidation state of oxygen in tetraisosulfate 6 acid? Now, tetraisosulfate 6 acid is H2SO4. That's the formula of tetraisosulfate 6 acid. So for you to obtain the oxidation number of oxygen in this compound is very easy, in that the oxidation number of oxygen in most compounds is -2. Take note of that. While the oxidation number of hydrogen in most compounds is +1. That's actually under the rules of determination of oxidation number of elements in their simple ionic representations, in their free state, in their compound forms. Alright, so for oxygen is -2 in most compounds, except you have peroxides, which is -1, and superoxides, which is -half. Then while that of hydrogen in most compounds is +1, except hydride. So this guy, the oxidation number of hydrogen here is +1, sulfur here is +6, oxygen here is -2. So the correct answer to that question is option C, as the oxidation number of oxygen. Then question 2. Question 2. When sodium reacts with water, the resulting solution is. When sodium reacts with water, the resulting solution is. So let's carry out the reaction. Now sodium is having a symbol Na, reacting with water. It reacts violently with water, alright, and then it forms NaOH plus H2, meaning that hydrogen gas will be released in the process. So trying to balancing the reaction, we are having 2, 2, then we can make this guy 2, 2 over here. That's 2 sodium, 2 sodium. Then hydrogen here is 2, so we can make this guy 2, so that it becomes 4. Then 4 hydrogens. Oxygen is 2. Oxygen over here is 2, so everything is balanced. So looking at this, they said the resulting solution is. Now we obtained sodium hydroxide as a compound with the evolution or the release of hydrogen gas. So let's get the nature of this guy. Now the nature of sodium hydroxide, is it an acid or is it a base? Is it acidic or is it basic? Now let's check the options. In the options, we are having option A as weakly acidic, then B neutral, C acidic, and D alkaline. Now this guy happens to be a base, so it must be basic. Is that you call it basic or you call it alkalinic? So the kind of solution that you obtain when you dissolve sodium or when sodium reacts with water violently is that it produces an alkalinic solution. So the correct option is option D, alkaline. Alright, so that's it. Then let's see question 3. I'm trying to manage the space. So question 3. In order to remove one electron from 3s orbital of gaseous sodium atom, about 496 kilojoule per mole of energy is required. This energy is referred to as. Now let me create more space. We are done with the question 1 and question 2. Looking at this question 3, in order to remove one electron from 3s orbital, then what's the question? Now, we are told that of gaseous sodium atom, about 496 kilojoule per mole of energy is required. This energy is referred to as, now, what is the energy that is required to remove electrons from gaseous atom? That's what they are asking us. If you must have read your periodicity of elements, that's coming from the initials of chemistry, then you tend to know that we have periodic properties of elements, which includes electron affinity, ionization energy, atomic radius, ionic radius, electropositivity, and electronegativity. Now, all these periodic properties of elements should be well understood. You should try to read up those periodic properties of elements. Now, let's compare electron affinity and that of ionization energy. For electron affinity, it is actually the energy that accompanies the addition of electrons to a neutral gaseous atom that is isolated, meaning energy is accompanying what? Addition of electrons. Then for ionization energy, it talks about the energy that is required to remove or pull off electrons from neutral gaseous atom that is isolated. So which one will make sense? Of course, the correct answer should be ionization energy. All right, this is the right answer because it talks about to remove one electron from 3s orbital of gaseous sodium atom. So assuming they had asked that the energy that is required to add electrons, so that energy that accompanies the addition of electrons is known as electron affinity. So take note of that. All right. Then, of course, that of activation energy is simply the minimum amount of energy that needs to be possessed by reactant particles for a chemical reaction to occur. So that one is out already. Then, of course, electronegativity is not part of it because electronegativity talks about the ability of an element to gain electrons and become negatively charged, which is not part of it. So the correct option remains ionization energy. So question 4. In question 4, the properties of electrovalent compounds includes the following except, meaning that amongst these four options, you must need to understand questions before attempting them. What they are asking us here is that among the four options that are given, three of them happens to be the properties of electrovalent compounds. Only one is not. So that one that is not automatically becomes the answer. So that was the reason why they ended that statement with except. So let's check. A, high melting point and boiling point. That is a property of electrovalent compound. As a matter of fact, if you must have read on chemical combination or chemical bonding, then you tend to know that we have electrovalent bond, we have covalent bond, we have metallic bond, we have hydrogen bond, we have the Van der Waals force, we have the London's force. Now, if you have studied much about your chemical combination, then you get to know that these bonds that are enlisted now, they are split or divided into two different groups. We have that of the intramolecular bonds and the intermolecular bonds. Intra talks about bonds that exist within molecules. Then while inter talks about bond that exist between molecules. So the two keywords, you must take note of them. Within molecules is for intra, between molecules is for inter. Then for the intra, what are bonds that fall under such category? We have bonds like electrovalent, we have bonds like covalent as well as metallic. Electrovalent bond is also called ionic bond. All right. So considering the properties of electrovalent compounds, it means they are actually compounds that possess electrovalent bond. Is that easy? Any compound that possesses electrovalent bond is called an electrovalent compound. And there are unique features of these electrovalent compounds. And one very important thing that you need to take note of about electrovalent bonds is that they are actually bonds that are formed. What precedes the formation is the formation of ions. That's the reason why electrovalent bonds are also called ionic bonds. Because for you to get the formation of electrovalent bond, for it to be formed, there must be the formation of ions, because it talks about transference of electron from an element which usually is a metal and then to another element which is a non-metal. All right. So the moment a metal loses electron to a non-metal, that metal gets charged, and of course it becomes positively charged. Then the non-metal that is gaining the electron becomes negatively charged before they get attracted, because unlike charges attract. So when they get attracted, they will now form compound. So what are some of the properties of electrovalent compounds. Property one is that they are characterized by high boiling and melting point. Another property is that they are good conductors of electricity, especially in their liquid forms or in their molten forms. Alright, and again they are soluble in polar solvents, for example water, and insoluble in non-polar solvents. Alright, so these are some of the unique features that you can find about electrovalent compounds. And let's check whether we have such. High melting point and boiling point. This is a property, so it's not the answer. Conduction of electricity in their molten state, which is also correct too. Then what about option C? High volatility at room temperature. This is actually wrong, because one very important thing that you need to know about electrovalent compounds is that they usually exist as solids. They are usually solids and hard at room temperature. So this guy here is wrong. Why? Because high volatility at room temperature simply means that they have the ability to transform rapidly into gas, which is not true about electrovalent compounds. So this becomes the answer, because this is not a property. Of course, option D, ionization in aqueous solution. That's still part of it, because NaCl is an example of electrovalent compound. When you place this in water, it can ionize to form what? Na plus and Cl minus. So that's to show that they can also ionize in aqueous solution. So this is also part of electrovalent compounds property. So the correct answer is high volatility at room temperature. Let's look at question 5. Question 5. Which of the following statements is not correct about electrolysis? Which of the following statements is not correct about electrolysis? Mind you, what is electrolysis? Electrolysis has to do with the chemical decomposition of a compound by the passage of direct current through the compound, either in its molten form or in its solution state. So what does that mean? Let's say we are having a compound AB and current is passed through it. It can dissociate to form A plus and B minus. We have just split this compound to its respective ions, and these ions can be associated with releasing gases. You get the point now? So one very important thing that you need to know about electrolysis is that it is the chemical decomposition or the splitting of a compound by the passage of direct current through the compound. All right, so that's for electrolysis. And of course, if you have studied electrolysis very well, you are post-UTME students already, so you should know what I'm talking about. Now, electrolysis takes place or occurs in an electrolytic cell. And if you know what electrolytic cells are, of course, you know the components that make up electrolytic cell. We have the electrodes and we have the electrolytes. Of course, electrolytes, they are compounds that conduct electricity and are decomposed in the process. Remember, I said electrolysis has to do with you passing current through a compound. What compound is that? It must be a compound that allow electricity to pass through. And such compounds are regarded as electrolytes. All right. Then why that of electrodes? Electrodes are simply materials in the form of wires, rods, or plates in which current enters and leaves the electrolyte. So when you have a beaker or a trough like this, and then you have the immersion of two rods, they will usually write this as positive and negative. The positively charged rod is called the anode. Both of them, they are electrodes, while the negatively charged rod is called the cathode. All right. So these electrodes are of relevance during electrolysis, because when ion starts migrating, remember that unlike charges attract. So what should migrate to this positive electrode must be a negative ion. Then the one that should come here must be a positive ion. And of course, when we say ions, one very important thing that you need to know is that there are two kinds. We have cations and we have anions. Cations and anions. Why do you say something is called cation? Cation, the full name is cathode ion. That's the full name of cation. Take note of that. Then why the full name of anion is anode. Anode, anode ion is also known as anion. Cathode ion, meaning any ion that should come to the cathode, is called a cathode ion. Hope you got that. Meaning that any ion that must migrate to the cathode must be called a cathode ion or what? Cation. Alright. And any ion that should migrate to that cathode must be a positively charged ion, because the cathode itself is what? Negatively charged. And remember, unlike charges attract. So if I bring, let's say, A plus, and I bring this guy here, it will make sense. Why? Because they are unlike charges. And this ion that migrated to this cathode, you will now call it cathode ion, or what? Cation. That's the reason why all cations are positively charged ions, while all anions are negatively charged ions, because anyone that should migrate here must be what? Negative. That's why you call it anode ion, or in short form you say an ion. Hope you got that. Then let's see which of the following statements is not correct about electrolysis. Now, if you look at this anode and you look at this cathode, the chemical reaction that occurs during electrolysis is called redox reaction. And I guess you must have heard of redox reaction before. Even in this my channel, I did video lesson on that. Now, redox reaction talks about two reactions that are taking place at the same time, meaning reduction and oxidation. So if I'm telling you now that the redox reaction is the one that occurs during electrolysis, it means that these two electrodes that must be present during electrolysis, one of the reactions will be taking place in one of the electrode, while the other takes place in the other electrode. All right. So now, between the reduction and the oxidation, which one occurs at the anode and which one takes place at the cathode? Is very easy. You can use this code CROWL to always remembering it, meaning C to arrow and A to O. What does that mean? It means cathode to reduction and anode to oxidation. So it means oxidation takes place at the anode, then reduction takes place at the cathode. So don't forget that. Oxidation takes place at the anode and reduction takes place at the cathode. We have different definitions of oxidation and reduction, but there is one that is of relevance in electrolysis. And what is that? The one of oil rig. This is a code. And what does oil rig stand for? Oxidation is loss of electrons, while reduction is gain of electrons. All right, so just have that in your head. So now let's see the question. Which of the following statement is not correct about electrolysis? A. Reduction occurs at the anode. Is that true? Let's check. At the anode, what takes place there? Oxidation. So, and now they are saying that reduction occurs at the anode. Is that true? No, because it's oxidation that takes place there. So this becomes our right answer. We've already gotten our answer already, because that's not correct. But let's confirm the others. Option B, anions migrate to the anode. That would be correct. Why? Anions, remember, they are negatively charged ions. And remember that anode is positive. So anions definitely will migrate to the anode, which is also correct. Then let's see option C. Positive ions migrate to the cathode. That's true, because cathode is negative. Remember, I have already explained this. So positive must come to the cathode, which is correct. Then D. Electrolysis conducts electric current. Of course, the background check about electrolysis has to do with using electric current, the passage of electricity, which is also true. So the only one that is wrong there is option A, which is reduction occurs at the anode. That is not correct. So let's see the next question. Question 6. The acid in butter is called dash acid. Now, there is an organic acid that is found in butter, and that acid is called butanoic acid, also called butyric. Butanoic is the molecular name, then while butyric is the common name or the trivial name. That acid is also found in the human sweat. Fun fact. So this becomes the answer to the question. Butyric acid is found in butter. Then question 7. We are given cesium Cs as 114, then 55, and then to produce E, then Az unknown, then plus 42, then alpha particle. So this is like alpha decay. So this alpha decay now, we are told to get the values of A and Z. It's very easy, because it said find the value of A and Z in the equation above. Now, it's very easy in that all you simply do is just to try to balance the reaction. So here, a total at the left, we are having 114 at the upper part. The upper part of this guy is 4. So what are you supposed to add to 4 now to get 114 is what? 110. So 110 plus 4 gives 114. So this value should be 110 for A. Then what about for the down part? This guy is 2. Then what are you to add to 2 to get 55? It should be what? 53. So 53 plus 2 gives 55. So what are the values of A and Z? It's very easy. 110 and what? And 53. So 110 and 53. Do we have it in the option? Yes. That is option C. So that's how you get answers to questions like this. This is under radioactivity. All right. So let's see the next question. Next question. So the answer is option C there. Question 8. If the pH of a compound is 3.2, this question is, I can say, the easiest. If the pH of a compound is 3.2, that compound is, now, on a pH scale, it ranges from 0 to 14. This is a pH scale. All right. Then 7 is neutral. Coming down like this, there is what? Increase in acidity. Then going up, there is increase in basicity or alkalinity. All right. So it means acidic solutions should be having pH values less than 7. Basic solution or alkalinic solutions should be having pH values greater than 7. So which value were we given in the question? The compound is 3.2, having a pH of 3.2. So that should be below 7. And if that is below 7, then the compound should be acidic. All right. So let's check the options. A, amphoteric. B, a salt. C, an acid. D, a base. So the most appropriate option to go with in this case is an acid. Assuming they had said the pH of a compound is 7, then the answer would have been what? Would have been neutral. You get? That's neither acidic nor basic. Then what about greater than 7? So if this value was, let's say, greater than 7, then it would have been what? A base. You understand? So the correct answer is an acid. Then let's see question 9. Question 9 says, when naphthalene on heating changes from solid state directly, keyword directly, to the gaseous state, it undergoes dash. So what this question is trying to tell us is a certain solid when heated gets converted or transformed from being solid to gas directly without passing through the liquid state. So solid to gas, this is like state conversions of matter. Solid to gas, that process is called what? Sublimation. So any solid that gets transformed to gas without passing through liquid state, that solid is said to be a solid that sublimes. So the correct answer to that question should be sublimation, which is option A, because the solid was converted directly to gas. Question 10. How many moles of hydrogen molecules are needed to convert 5 moles of oxygen molecules to water? Now, looking at this question is under stoichiometry. It's very easy. All you simply do first is that you represent the equation. Now, the equation is a reaction between hydrogen gas and oxygen gas to form water molecule. Now, balancing this reaction, this is like the simplest equation in chemistry. The reaction is balanced. If you want to confirm, we are having 2 times 2 for hydrogen, 4. 2 times 2 here is also 4. Oxygen here is 2. These two are affecting everything, so the oxygen becomes 2. So everything is balanced. So how many molecules or how many moles of hydrogen is required to react with how many moles of oxygen in order to get a water molecule by standard? Is what? 2 moles of hydrogen requires 1 mole of oxygen. So if 2 moles require 1 mole of oxygen to form water on standard, then they are now asking us how many moles of hydrogen, meaning unknown, how many moles of hydrogen would now be required or are needed to convert 5 mole of oxygen. So now we know that it is 5 mole of oxygen. So what are you supposed to do from here? Is very easy. All you simply just do is just to cross multiply. When you do that, 2 will multiply 5 to give 10, x will multiply 1 to give x, which is x. Our unknown value now is equal to what? 10 mole. So our answer to that question is option B. So let's see the next question. Question 11. If an element has the electronic configuration 1s2, 2s2, 2p6, 3s2, and 3p4, it is dash. So considering this element, there are ways that students can use to obtaining the element by simply adding up this power and then you get the atomic number of the element. Now when you add up these powers, these are the number of electrons. So 2 plus 2 plus 6, that's 10, then plus 6, that's 16. So it's obvious that this element is sulfur because sulfur is found in the 16th position. So sulfur happens to be a non-metal, you get. So you can just check. Is it a metal? No, it's not. It's a non-metal. Then B, an alkaline earth metal. So A and B, they are wrong because it's a non-metal. Then C, an S block element. No. D, a P block element. Yes. How can you tell if an element is an S block element? It's very easy. Now, any element whose electronic configuration ends in the S orbital, such element is regarded as S block element. You get the point? Then those ones whose electronic configuration ends in the p orbital, they are called p block. That's the reason why group 1 and group 2 elements are S block. Don't forget this one. Then 3 to 8, group 3 to 8 elements are P block. Then the D block elements are the transition elements. Then while that of the F block element talks about the inner transition elements, that's the lactanite and the actinide series. So this guy here, since its electronic configuration ends in the p orbital, then this is a p block element. Assuming here was S, then it would have been what? S block element. So the answer is D. So let's see the next question. Question 12. In the preparation of carbon monoxide by heating ethane dioic acid with concentrated sulfuric acid, the concentrated sulfuric acid acts as dash. First and foremost, when you want to prepare CO, because CO is one of the oxides of carbon, that's the carbon monoxide, because the formula of that guy is CO, that's carbon monoxide, all right? So for you to prepare this CO in the lab is by the dehydration of either formic acid is also called methanoic acid, or by the dehydration of ethane dioic acid, which is in the question, also called oxalic acid. So another name for this compound is oxalic acid. So it's either by dehydrating any of them, either of them. So if you dehydrate using concentrated sulfuric acid, which functions as the dehydrating agent, then what happens? It's certainly going to produce that CO. Now, let me show you using that of formic acid, methanoic acid. Methanoic acid is HCOOH. When you dehydrate using conc H2SO4, concentrated sulfuric acid, you are going to obtain CO while you have eliminated what? A molecule of water. And water can come in the form of OH and H in combination to give this guy H2O, because we have 2H and 1O. Then we are now left with what? We are left with CO to give us CO, which is carbon monoxide. This is the dehydration of methanoic acid. Methanoic acid using concentrated sulfuric acid as the dehydrating agent. Then you can also use this same concentrated sulfuric acid on ethane dioic acid, which is this guy. And the formula of ethane dioic acid is given as COOH linked to COOH, because when we say dioic, simply means two carboxylic functional group in the compound. So when you heat this guy using concentrated H2SO4 functioning as the dehydrating agent, bearing in mind that you are to remove a molecule of water, so minus H2O, where would the H2O be coming from? It's either you are removing OH from here and you are removing H from here, or you can decide to remove your OH from this place and remove H here. It's the same thing to form water. So this is our water that has been removed. Then we are now left with CO and COO. Now CO is written as that, then COO can be written as CO2, because COO is still same as CO2. So obtaining these two, let's say for example you are now expected or you are more interested in obtaining CO and you don't want the other guy. So what are you supposed to do? Since you have already obtained these two, and of course most times these two, whenever you are using this guy, this ethane dioic acid, remember I said it's also called oxalic acid. Whenever you are dehydrating this guy using concentrated sulfuric acid, there is every tendency of you having equal volumes of CO and CO2 being produced as products. So what are you supposed to do if you are more interested in obtaining CO? It's very easy. All you simply do is to pass this mixture through concentrated caustic soda, which is NaOH. Why? Because this concentrated caustic soda has strong affinity to binding onto what? Onto carbon dioxide, which is CO2. So it tends to trap CO2 from a mixture of gases. Then you've successfully removed that CO2. When you have already passed the gases through that, then of course you'd now be left with your CO. So what is now the answer to the question from my explanation? The concentrated sulfuric acid now functions as what? The dehydrating agent. So that's the answer to the question. So let's see question 13. In question 13, we were asked how many unpaired electrons are there in an atom whose atomic number is 8? Let's say we are told that the atom is atom X. Now the atom X has an atomic number 8. So since there is no charge, it's just of an atom, there is no charge, the atomic number, which is same as the proton number, will also be the same as the number of electrons. Remember that when an element is uncharged, meaning it's not carrying any charge, it is in its atomic form, the atomic number of that element, which is also called the proton number, would be the same as the electron number. And remember that when you are filling orbitals, what do you feel? You feel electrons and you don't feel protons. So they are asking for the unpaired electrons. So how do we go about it? We can only get it by using our orbital configuration, filling electrons in orbitals, talking about those 1s, 2s, and the rest. Now, 1s has a small box, then 2s has another small box, then next is 2p. I think we have to stop here because the maximum that everything can accommodate here or hold here is 10. So since we are talking about 8 electrons, then let's see how we can go about it. We pair instantly. 1, 2, then 3, 4. Then when you get to the p, because p is a degenerate orbital, then you have to fill singly before you start pairing. So already we filled for 4, so it becomes 5, 6, 7, then what? 8. So looking at this expression now, we are having it as 1s2, 2s2, and 2p4. So when you sum up, you get a total of 8. But that was not what they asked us to get in the question. What did they ask us? They told us to get the number of unpaired electrons. So how many electrons are just on their own, single, without any other electron in combination with it? Let's check. These ones, they are paired. These ones are paired. This first part of this 2p is paired, but the last two, they are unpaired. So we are having two to be what? Unpaired. So we have two unpaired electrons, which is option C. If you really want to understand about the orbital concept and how you can get the correct orbital representation of elements, how you can fill them appropriately, just stay glued to this channel because I'm going to be treating a particular aspect of that. I will just treat on that and then explain the concept about orbitals and orbital configuration, the rules that you need to obey, because we have rules. You don't just fill anyhow. There are rules, about 3 of them: the Ohm's rule of maximum multiplicity, Pauli's exclusion principle, as well as the Habermas or the building up principle. So those are things that I would explain in this channel. So that's that about that. Then let's see the next question, which is question 14. In question 14, we are told how long will it take to deposit 0.08 gram of copper from copper chloride solution by passing a current of 0.5 amperes. Then we are given the relative atomic mass of copper to be 64, then the farad to be 96,500 coulombs per moles. This question is under electrolysis. That's Faraday's calculations, first law and second law of electrolysis. Now, how do we go about this? My Rema code, my Rema formula is giving us atomic mass, when you see questions like this, just work with this formula. Atomic mass is given as charge times farad. Then mass deposited is given as current times time. Remember the question was how long? How long simply means time. So it means it is this guy we are told to calculate. How long? So how do you work with this almighty formula? It's very easy. Just cross multiply, meaning that this multiplies by this and this equal to this multiplied by this and this. Is that easy? Alright. So since we are told to get the time, how do we go about it? Our mass deposited was 0.08. So I will just impute. Our mass deposited is 0.08. Then what about the atomic mass? The copper in question, the atomic mass is what? 64. So up 64, then equal to, or to, let me use an arrow instead of using equal to. So we better that way. Then what is our charge? Of course, the charge of copper in question, the element in question in this compound would be Cu2 plus, because it's obvious these two came from this charge that copper was carrying. Then it becomes what? Plus 2 times what's now the farad? Farad is 96500. Then what about our current? The current that was stated is 0.5. So 0.5 times what's the time? Unknown. That's what we are told to find. So what are you supposed to do? Just cross multiply here. Then it should give us 64. 64 times 0.5 times x equal to what? Equal to 0.08 times 2 times 96500. So is that easy? So with the help of our calculator, we can easily get our answer. So let's multiply 64 times 0.5. 64 times 0.5. That should give us 32. So 64 times 0.5 is 32. So 32x equal to, then 0.08 times 2 times 96500. We obtained 15,440. 15,440. So when we divide by 32, we are to obtain, we obtained 482.5. 482.5. So this is in seconds. So for we to convert this to minutes, because remember that 60 seconds make a minute. So how do we now convert this guy to minutes? If 60 seconds make a minute, then 482.5 seconds will make how many minutes? That's the question. So it means we have to divide this guy by 60. So we'll divide by 60, that is 482.5 divided by 60. We obtained 8.04. So approximately 8 minutes. 8 minutes. So it means that our answer to this question is 8 minutes. So that's the correct answer to the question. Then next, let's look at question 15. Question 15, we are asked that the shape of graphite crystal is dash. You know that graphite is an allotrope of carbon, just like you having diamond to be another allotrope. So graphite and diamond, they are both crystalline forms of allotropic forms of carbon. All right. So looking at, they said they are asking for the shape of graphite. Now the shape of diamond is octahedral, while the shape of graphite is hexagonal. So the correct answer is option D. So it's with my hope that these 50 questions that we've looked at and some other subsequent questions we are going to be looking at too, then the previous ones that I have looked at in this channel, I hope that it will be of help to so many students that are preparing to writing their various post-UTME examinations. So if you are still new to this channel or you've been a member of this channel and yet you have not been a subscriber to it, do well to hit the subscribe button and always stay tuned because more updates are here to drop. Turn on that notification bell beside the subscribe button in order for you to be the first to get notified when I upload new content or new videos. Thanks for watching and stay tuned as more videos are yet to come.